Hello, welcome back for part 3 of our barycentric teleportation mechanics. So this video we're going to actually implement the library functions that we've created. And so let's go ahead and give ourselves just some quick ways to test this before we create some more robust tools for it. Because I'm a huge fan of robust tools, but I like to make sure everything's working as intended before I begin messing with stuff like that. So we're going to do this by creating ourselves a new blueprint class, just general actor. We're going to call this a post. And what we're going to do here is we're just going to create something so that we can do a get all actors, and we can just test to see if this is going to work. So I'll go in here. Here's our post actor. I'm going to add in just a visual representation from we're playing. And I'm probably going to just shrink that down to like 0.3 or something a little bit smaller. And in the construction script, I want to give this thing a tag that we can find. And so I'm going to drag out from my construction script, and I'm going to say get tags. Actually, get tags. And I'm going to specifically clear this off the bat, just because I know if we start adding tags dynamically to an actor in the world, if you don't clear it right away, it's going to keep adding adding at the end of it. So you can potentially get an actor with like 100, 200, huge number of tags. So be sure to clear this if you're doing it this way, right off the bat, just so that nothing crazy is going on. I'm going to say add then, so I'm going to add a new tag to it. And I'm going to promote this to a variable because I want to be able to set this in the world. This is going to be my post tag. And I'm going to expose this and make sure that we can edit it when it's in the world. And I'm just going to have it default to none. I don't really care about it. And that's all this post really is. It's just something that we can place in the world and have a point that we can reference. And so what I will do here is I will drag here, and its tag name is going to be this is going to be source A. And I could just honestly, if I want to, just drag something and type in tag, and I could edit here. I guess I could do it that way too. It doesn't really matter anymore because we've just created that. So a little extra step, no worries. And so I'm going to make myself a triangle here that I can stand in. And let's make sure that they're all actually on the same level. All right, we'll call this one source A. Drag and copy. This is source B. Drag and copy. This is going to be source C. All right, and so there's our 3 for sources. And what I will do here is I will select these other 2, and I'm just going to copy, and I'm going to drag those over here in the world, so that we can have basically a target region that we're going to end up going to. And we will change this one to be target A, this target C, and target B. And this is kind of our only requirement as far as aligning things. It just basically generally has to be, you'll teleport out of this, positionally. You just need to make sure that these correlate. So this is A, this is A, this is B, this is B. So that at least has to kind of match, because if those 2 are flipped, then we'll end up, and instead of if we're over here on this triangle, we'll end up, instead of over here, we'll end up over here on this triangle, because it's going to look for that point. So it's one of those, be aware that at least has to matter. Basically, the way you walk around your triangle has to be the same. You can't change the direction you're walking effectively. Okay, so everybody's had their names properly changed. We're going to go in here. We're going to grab ourselves the first person actor here, and we're gonna modify him a little bit just so that we can do this. And so instead of spawning projectiles when we shoot, we're going to drag this this fire action down here, and we're gonna start overriding that. So we're gonna say this is gonna be get all actors of class with tag, and we're gonna look for our post, and I need 3 different actors because I have 3 different tags. So I'm gonna copy this just like that. And what I'm going to do is get a copy. I always want the 0 copy from these because we know that we're only going to have one of them for each of these tags. And so this is kind of the really, really dirty way of doing this. I don't want this to be the final implementation of this. This is just so that we can very quickly see without building any tools, just that it's working. This is going to be source A, source B, and source C. We want to get world location or get actor location. Oops. Go back. Control. Let's try that again. Control C, Control V, Control V. And we'll just promote this to a variable so we can store it real quick. This is going to be A, our source A. And we'll promote this one. This will be source B. Promote this one. And we'll call it source C. Grab ourselves a sequence here. Connect everything up. Add ourselves another one for at the end here. Make sure that we actually do wire in our value setting. And then we just need to call our functions. This is going to be our get barycentric, or actually no, sorry, calculate. Where is our function? What do we call it? Convert to. So convert to, why are you not showing up? Convert into. Convert into barycentric. Plug that in, and we know that we need our points. So I will grab my value for point A, grab my value for point B, and grab my value for point C. And we also need to grab a reference to ourselves. Get actor location. And this is where we currently are. And so instead of trying to teleport anywhere right now, what we will do is we will just print this value, and we will print that value as well. So I'll Control C, Control V. And so the first thing we're going to do here is we're going to plug our coordinate values in, and we're going to plug in is valid. So we can just kind of real quickly get a print statement example of what's going on when we pull this trigger. So right now, let me pull it a couple times just so we can get that out of the way. So it's showing is false. So right now it's telling us these are not valid coordinates. And I can kind of move around, and as I get closer, you'll see they're still false. Once I step inside, the values are less than, if we just taking a look here, 0.4, 0.2, 0.3. These should be good. These good values. Oh, looks like I was slightly off somewhere. But yes. Let's add those together and actually see what it's telling us. So we're going to get our vector length. Plug that in instead. So 2, 2, 2. The question is, why is it telling us that 0.6 is a bad value? Over here, convert into barycentrics. Okay. So yeah, so it looks like the issue is you can see the rounding error here. There are some points where our rounding error is barely not working right. And so it looks like we may need to kind of have that. Let's try 0.3. That'll give us a little bit more range on where we can actually go. And so this is one of those kind of, if you want to adjust how sensitive it is to you being within the boundaries of it. In some cases, maybe that's not going to be an issue, but we can kind of adjust what its sensitivity is. And so now it's happy, we're inside of it, these are valid. If I step over the line ever so slightly, it's false again. So there we go. So that I'm pretty happy with. So let's go back to our first person character, and instead of just doing print statements, let's actually test this out with a teleport. And so I will recombine these pins, and we will do another sequence here because we need to get another set of 3 actors. So I'm actually going to just copy that, and I'm going to paste that again. This is a good example of why we want to make a better tool for this, because this is a lot of get all actor nodes just for teleportation. This is not efficient. This is not good. But for testing purposes, this is absolutely fine. So if you remember, instead of calling it source A, we called it target A, and target B, and target C. So I will change those names real quick. And we'll promote each of these to a variable. This will be target A. Promote to variable. Target B. Promote to variable. Target C. Compile that, and then we'll add one more pin in. And so now what we can do here is we can say convert, we called it convert out of Barycentric. Did I have spaces in that? I don't want spaces in that. Barycentric. Convert out of Barycentric. And so we now just need to plug in our target A, target B, and our target C. And we will also plug in our UVW coordinates. And we will just set actor location to our new coordinates. Now, right now, I'm leaving this so we don't actually have any logic set here for if it's going to do this, if these are good or bad coordinates, and I'll show you why here real quick. If I do it outside of here, I'm going to end up somewhere really far away. Like this is going to start going crazy there. If I'm inside, though, I will end up inside of my other triangle. So let's add in that real quick check there so we can kind of make sure that we are not going over the edge, because we want to test. I want to test some of the other points, not just the center of this. So if this is a valid coordinate, we will continue everything. If it's not, it'll just stop here, and we'll give ourselves a quick print string of like outside zone, outside teleport zone. Here we go. So if I click this now, I'll get that warning, outside teleport zone. If I go inside, so let's say I'm right next to that one. I'm now right next to that back corner one. And if I put this over, I can't do it out. I can't go back and forth yet. We don't have that kind of a logic. This is kind of a one-way testing concept right now. And so there we go. I'm inside, and I'm next to the proper little dot here. The idea being that now, and this is where it gets really, really cool. At least I think it gets really, really cool here. Now, these don't have to be the same shape. I can put this way over here if I want to, and like we can, you know, make this, it's like this is next to something important. Let's just drag this box over here. Yeah, some hidden boxes or something to hide behind. I could drag this one like right over here, something like that. I could drag this one, you know, way over here. And so you'll note then that the shape of this triangle and the shape of this triangle are vastly different, but it doesn't matter. This is where it gets really, really cool. So I will go next to this dot here, and if I'm inside, I will end up right here next to this one. If I go next to, so if I'm closer to this dot here, I get closer to the forward dot. And so that's how, and that's the power of the barycentric coordinates. Like I said, they're scalar. They're very much invariant. They don't have anything attached to them. So I will simply go from a point in one triangle and wind up in the equivalent point in the other triangle. And this is where it can be really, really cool and useful, because we could have, you know, this could be a map on a wall, you know, and we could, you know, or, you know, any kind of, you know, imaginations, you know, running wild, any kind of shape you want, and you'll end up in some sort of a valid region within that other triangle. And it can be a very, very cool thing. So, oh wow, we are really far away. Am I moving? I'm moving. Let's jack that up to 8. Let's get back there. You know what? Let's just do this. Double click. Now we're back. I have no idea where we went. That was kind of crazy. Okay. So now let's actually make ourselves better tools that we can talk to with this. So we're gonna make ourselves like a teleport actor, and we're gonna make ourselves kind of an interface to work with. So the first thing then, let's make the actor, because that's going to be fun. So here we go. Here's an actor. We will call this teleport. Actually, I'm going to delete that because we want to not do that in blueprints. I'm going to do that in the content. All right, we'll call this TeleportZone. And we're going to use a spline for this, which is really kind of fun. What I'm going to do in here is I'm going to add myself in a spline component, because splines are ridiculously useful. And I'm going to position my initial spline point at like -200, -200. It's going to be our bottom left point. And then for this extra point here, then everything should be relative to that. So I will go to 400x. And no, that's too far. No, I am right there. So I am there. And then I'm going to drag out from here to create a new point, and I will make this one 400, 400. And I'm going to go back here, and I'm going to set all these spline points from curve to linear. And keep you as linear. Make you linear. And there's going to be an issue with going around this direction. We will talk about that in a minute after I show you the issue. So this is one of those, just as a forewarning, this is not the final position of this particular vertex. Anyway, I'll alt-right click, drag out another point, and then this is going to be 0, 400. So there's our 4 points. I'm not going to worry about connecting them. And so now we have 4 points on a spline that we can use their positions of. And so to make this useful to us visually when we're placing things, we're going to make ourselves a dynamic mesh that we're going to end up creating. So we're going to go over here and we're going to say add dynamic, let's add mesh component, or actually it's not even add, it's going to be create mesh. Should be procedural mesh. Add procedural mesh component. There we go. And that's what we're going to do on construction. it's relative. I'm going to split this because I know it's going to get angry at me if I don't have it. That's fine for its relative position. And we need to add into it. Two triangles, or it's triangles and such. So we're going to go to add. Sorry, no, not add. It's going to be create mesh section. And if you've never worked with this node beforehand, your first exposure to it might be a little bit nerve-wracking, because you're going to see a lot of these arrays that it wants. Do not worry. The only two that we really have to give it 100% are the vertices and triangles. And so this is really what we're going to use. We're not going to worry about the rest of that, and we're just going to have it in one section. So knowing that, I'm going to give myself a constant local variable, and this is going to be called triangles. And I will make this an integer. I will make this a array of integers, and we'll deal with that later, but this will go here. You'll note though, if you mouse over this, triangles does require its length to be 3. So this is the logic here is the fact that when you populate this, if I populate this, for example, with 1, 2, 3, or sorry, 0, 1, 2, for example, it's going to look at this array and it's going to grab entry 0 as the vertex position of triangle 0's one of its points. It's basically going to draw a triangle between the world positions, or the positions we give it, 0, 1, and 2 in this array. So we need to populate this array with the positions of our spline. And so what I'm going to do here is I'm going to create this, and I'm going to reduce it to a macro just for cleanliness. So I'm going to grab this, I'm going to do a for loop. We know we have 4 points, so I'm going to go from 0 to 3. And what I'm going to do here is I am going to create a variable, and I'm going to call it vertices. I'm going to change that to a vector. And what I will do here is I will drag this out. I will get this. Just to be 100% consistent, I'm going to make sure I clear this before I do anything with it, just to make sure we have an empty list, or an empty array that we can work with. And then I'm going to add in some entries. I'm going to add my entries in based on my spline position. So I'm going to say get position, get location, actually, at spline point. And I want to, for this particular case, I want to stay in my local coordinate system. I want to stay in my relative. So I'll grab that, and then instead of just always grabbing index 0 from my spline points, I will grab whichever loop I'm on. So the first time I will grab spline point 0, then spline 1, point 2, and so on. And then we will basically feed that kind of knowledge into our mesh that we're going to create. So drag out from here. I'm happy with this, and I'm going to collapse this down to a macro. And this is going to be populate vertices macro. I'll drag that out over here. Now if I hit compile and I go back to my viewport, we're not going to quite see anything yet because I haven't told it what to draw yet. So we know that we want we want triangle 0, 1, 2, and I also want triangle, so we want, looking at this, let's go back to the viewport. So 0, 1, so here's the issue. So 0, 1, 2 is this one. I'll bet you if I go underneath it, yeah, there it is. So this is currently one-sided, so that's why we didn't see it initially. And then I know I want the other one. So if we call this, this, if we're talking about this way, we need to make sure we're setting it properly. So 0, 1, 2, and then 1, 2, 3. Compile that, And now it's not going to be quite right. So let's fix that issue just now that I was talking about beforehand. I'm going to go over here, and I'm actually going to set this guy to that position. I'm going to drag it slightly. Oops. Which one did I grab here? There we go. I'm going to drag that out, and I'm going to make him 400 by 400. So I'm getting this kind of angle here, because this is 0, 0.1, 0.2. That'll be one of our triangles. And then 0.1, 0.2, 0.3 will be our other triangle. So we'll draw this one. And so this one is being drawn properly. This one isn't. And so this is one of those situations where we need to, it's basically the direction we're drawing it matters. So instead of drawing it 0, 1, 2, we need to draw it from 1, so 0 to 1. So let's go over to our event graph here, our construction script, and instead of drawing it from 0, 1, 2, we're going to draw it 0 to 1. If I hit compile, I then see the entire completed thing, because beforehand we had an issue with, you know, one side was up here, the other side, its forward was on the other end. The last thing we need to do then in our construction script is shift this down ever so slightly. So for its relative location, we're going to shift that down to -200, -200, -200. Compile that, and now our viewport lines up. And so what I can do here is, if we drag this into the world, we now have this two triangle region that we can treat as like just a block. And because we're using splines, I can click on a point, for example, and I can begin dragging it around. So I can begin just kind of changing the shape of any of these teleport regions to whatever I feel like, which is kind of cool. And so what I will do here is I will make a material just so that this is a little bit cleaner in the world. This is going to be TeleportZone mat. And we're going to make this into a translucent material. I will give it a vector, call it color. I'll leave it as black for now, and you'll see why. I'll give it a scalar value, and I will call this opacity. I'll set that to like 0.2. Apply, save. And if we go back into our teleport here in our construction script now, what I will do here is I'm going to drag out from here, and I'm going to add in a sequence just to keep things clean. And from here, what I'm going to do is I'm going to add a dynamic, or create a dynamic material instance for this object. We're going to select our teleport zone material. And now if I compile it and just show you, it's now black instead of gray, but we want to take that one step further. We are going to set a vector parameter value, and we are going to promote our color here to a variable. We'll call this zone color, and we'll make it visible. Make sure that we're actually adjusting the color parameter, and I will make this default itself to something better than black. So let's go with like a greenish color here. But now on the first person example map, I have this, and I can dynamically, just by selecting the shape itself, I can change its color. I can change it whatever I want to here. So if I need to do just some indicators and such, and I can make this visible only for, you know, a hidden, you know, I can make this hidden in game, for example, so that we can't see it. But we still want to see it right now. I will go and set for our teleport zone. I'm going to click here, and I am going to change its collision to overlap all dynamic, just so we can walk through it. And now if I hit play, I have a region here that I can kind of walk through, and it's, you know, it's much nicer to work with. It's much clearer, like where can I stand, where am I standing relative to this, rather than trying to say like, okay, 3 points, am I on the line or not, that kind of thing. this is going to be a much better way to be able to tell teleportation regions. And you can decide whether or not you want to leave that in game or not. All right. Last thing I'm going to do is I'm just going to pop this out. I'm going to promote this to a variable just because I think it's going to help us with a little bit of color. Just type in normals. And I'm just going to give, this is basically a normal per vertex. I'm just going to create 6 of these and make them all point up. There we go. All right, so there we have now our teleport zone. We can kind of drag in multiple ones now. Oops. Multiple of these, and I can, position them wherever I want. Change its color. Let's make this one reddish. And we'll leave this one over here. We'll just drag it over here, a little bit farther over here. And we'll leave that one as greenish. And so the idea now is we're going to want to talk to either one of these, and we want to be able to go back and forth. So let's set that up. So the first kind of communication we're going to need is we're going to need a blueprint in a communication so that we can get or easily get these spline values from this thing. So let us go to blueprints. We'll add a new blueprint interface. I will call this TeleportZone interface. Let's rename that properly. And we'll call this one request. This is going to be request relative position, request UVW. And I think I'm actually going to break up the video here into 2 different parts for this last section, just because I know we're starting to, I think, hit like a half-hour mark somewhere. So when we come back, what we're going to do is we're going to actually set up the interfaces, and we will set up how we're going to end up communicating with these zones as a player.